Hey guys, so for predicting outcomes, the outcomes of an unbiased sample are proportional to the results of a population. You can use unbiased sample results to make predictions about the population. Biased sample results should not be used to make predictions about the population. So look at number 5. Green Valley Middle School conducted a survey of 125 random students, asking them how much time they spent each night on homework. Now we can see our result in the table to the left. What percent of students spend no more than 30 minutes on homework each night? So we look at the table, no more than 30 minutes means that we wouldn't go over 30 minutes. So I got 0 to 30. There are 4 students out of my 125 random students. So 4 out of 125, or buying time, so I can divide it in my calculator, 3.2%. What percent of students spend at least 31 minutes on homework? So that's any above 30 minutes. Well, you could add 64, 25, and 32, and you get 121 over 125. Or, because it's at least 31, we could just subtract 4 and get 125. And there we should have 96.8%. If there are 1,200 students in the school, approximately how many would you expect to spend more than 1 hour on homework each night? So just looking at the probability, we look at 25 plus 32, or 57 over our 125. And that would give us the probability of how many of them would do over an hour. Just like in our theoretical and experimental probability, we're just going to take that fraction and multiply it by 1,200. So I'm calculating this in my head right now. I'm not using my phone as a calculator. Carry the 1. Okay, add 2. I think it should be, it should be 547.2. So roughly, or about, 547 students. So more than 1 hour each night on homework? That's a lot. That's a lot of homework. Huh. Maybe I should be giving out more homework. If this many students do, I'm not giving enough. All right, I'll start giving out more homework. Thanks, guys. I'll do that then. Number 6. An Italian restaurant asked 150 random customers what type of pasta they preferred. Results are on the left. Excuse me. What percent of people surveyed say spaghetti or macaroni? So I'll take my spaghetti total, my macaroni total, and add them up. Yeah, I got 90. Out of my 150. 90 divided by 150. 60% of people said spaghetti or macaroni. What percent of the people did not say spaghetti? So again, did not say. You could just add up these 3 numbers, or you could take the 150 and subtract 72. You'll get 78 over 150, or 52%. If the restaurant is ordering 500 boxes of pasta, approximately how many should be linguine? So then we can take the linguine number, put it over my 150. So I got 21 over 150. And just like in number 5, and in the theoretical and experimental probability, we'll multiply that number by 500. So I got 21 divided by 150. Multiply that by 500. They should order 70 boxes of linguine. I love linguine. It's so good. I'd be in that linguine big numbers. It's so good. A landscaper offers 3 colors of mulch: red, black, and brown. They randomly survey their customers to see what they prefer. Of these customers, 62% prefer brown, 22% prefer black, and the rest prefer red. If they are ordering 800 bags of mulch, how much should be brown? Well, they already found our percent for us. So looking at the percent brown, we have 22%. That as a decimal is 0.22. You can just multiply that by 800. That was a gross noise, I'm sorry. 176 bags of brown mulch. If they're ordering 800 bags of mulch, how much should be red? Well, we have to figure out what the percent of red is. So I could take 62 and add 22, and you would get 84. So black and brown together would be 84%. I could take 100 and subtract 84, and see that 16% of people prefer red mulch. So I can take that 16% as a decimal, 0.16, multiply it by 800. Oops. You get that 128 bags should be bought of red mulch. Okay, go ahead, try the worksheet. Let me know if you have any questions. Okay, bye.